Hello, everyone, and welcome to Algebra 2. This is Chapter 9, Section 9.1, Right-Angled Trigonometry. So trigonometry is the study of the relationships between the angles in a triangle and the sides of a triangle. So just as a little example, if I had something that had a very small angle, then the side across from it would be really small. But if I decided to make that angle bigger, then I would also have to make the side across from it bigger. I could leave this side the same, but it would also affect this side. So the relationship there between how big the angle is and how big the sides are is the study of trigonometry. So somebody gave names to all these different pieces of the triangle and all the different relationships. So in a right triangle, this little symbol means right triangle or 90 degrees. This Greek symbol here is pronounced theta. So just like we often use x's in algebra, we often use theta to represent angles in trig. The side across from the 90 is the hypotenuse. And if this is where you put your theta, then we're just going to call this side over here the opposite side, and this side here the adjacent. So if you're not familiar with the word adjacent, it just means next to. So two books might be adjacent. That means they're just next to each other. But notice that if I decide to put theta up here, which is definitely going to happen, then this suddenly becomes the opposite side, and this one becomes adjacent. So be clear that opposite literally means opposite the theta, which is what I was saying over here. The theta and this opposite side are definitely related. But no matter what you do, the hypotenuse is always the one across from the 90-degree angle. So here's the names that they gave to them. So they have abbreviations, but I'm going to write it out for you. This is pronounced sine, not sin, sine. And sine is the ratio that the opposite side makes with the hypotenuse. So just as an example, if this is a 30-degree angle, then this ratio is 1 to 2. And that's just a known fact. For every triangle in the world, the ratio is 1 to 2. And we call that sine of theta because that is the relationship between the opposite and the hypotenuse. So another one is cosecant. So we're always going to say cosecant even when you see this little CSC. And that is just sine flipped upside down. And for some reason, you wanted to tell somebody the relationship between the hypotenuse and the opposite side, you'd give them cosecant. So cosecant of 30 is 2 over 1. This one is pronounced cosine, and it's adjacent over hypotenuse. This one is pronounced secant, and it's hypotenuse over adjacent. This one is pronounced tangent, and we'll never really write the word out again. You're always going to write tan, but you're going to pronounce it tangent of theta. And this last one is cotangent. We don't say cot theta. We say cotangent of theta. All right, so we're just going to do some examples, and I think once we do some examples, you'll understand. So you're given a right triangle, which means it's going to have a 90-degree angle in it with side lengths 5 and 12, and they want you to put the angle theta opposite the side 12. So I'm going to not draw it perfectly to scale, but I'm going to try and draw it a little taller than long since this is 5 and 12. I'm going to make a right triangle, and this is where the theta is going to go because they want it opposite the 12. So the first thing you have to know is the Pythagorean Theorem. Pythagorean Theorem, which if you had taken geometry first, you would know well, but it says that in a right triangle, a squared plus b squared is equal to c squared. Although I always think of it as leg squared plus leg squared is equal to hypotenuse squared. So these are called the legs of a triangle. So 5 squared plus 12 squared is equal to the hypotenuse squared. And you can use that to find the hypotenuse. So 25 plus 144 is equal to h squared. H squared is equal to 169. H is equal to 13. So there are certain triangles that you're going to see over and over and over again. They are called Pythagorean triples, just ones that work really nicely. So 3, 4, 5 is a pretty famous Pythagorean triple. That means if you drew a triangle with legs 3 and 4, the hypotenuse is going to be 5. Well, now you've just found another one, 5, 12, 13. As you find them, you might want to keep them on your appendix and keep them handy. All right, so if you have a triangle that looks like this, then sine of theta is somebody's way of saying, literally, this whole question, what is the ratio of the side opposite the theta to the hypotenuse? That's what you need to be thinking when you hear somebody say, what is sine theta? It is the ratio of the side opposite theta to the hypotenuse. What is cosine of theta? It's the ratio of the side adjacent to the hypotenuse. And what is tangent of theta? It is the side opposite to the adjacent side. So it's the ratio of opposite to adjacent. These are the most famous three. The other three are not used anywhere near as often, and I always write these three first because the other ones are just the flips. So cosecant of theta is the flip of sine because it's hypotenuse over opposite. And secant of theta is the flip of cosine. So it's hypotenuse over adjacent. And cotangent is the flip of tangent, so it's adjacent over opposite. There you go. Let's do another one. In a right triangle, theta is the acute angle. So just so we don't get into a bad habit here, I'm going to put the theta up here. I don't want you to think it's always in the lower corner. Now they told me that sine of theta is 4 over 7. With just that information, I can figure out the whole triangle. So its opposite is 4, and then the hypotenuse is 7. Then using the Pythagorean theorem, I can find this missing side. So 4 squared plus x squared is equal to 7 squared. 16 plus x squared is equal to 49. X squared is equal to 33. X is equal to the square root of 33. So this is not a Pythagorean triple. So I can cross this off now and just write square root of 33. It is technically plus or minus, but in this case, it's telling us the length of a side, so it's only going to be the plus. So not a Pythagorean triple, only ones that come out perfectly. So now they want us to evaluate cosine. Cosine is adjacent over hypotenuse. So I still don't know what this angle is, but I know the ratio of the adjacent side to the hypotenuse is going to be the square root of 33 over 7. And then tangent of theta is opposite over adjacent. So 4 over the square root of 33. Now you can't leave it like that, so I am going to rationalize the denominator and multiply both the top and the bottom by the square root of 33. And my final answer is 4 square roots of 33 over 33, which doesn't look helpful to you right now, but we're going to eventually do word problems, and then you'll see why people need trig. Number 3, using the triangle below, find sine of theta and tangent of theta. So I'm not going to teach anything new in these next two problems. You might want to try them on your own. So first off, let's get this third side here. So x squared plus 5 squared is equal to 5 square roots of 2 squared, which gives me x squared plus 25 is equal to, when you square the 5, you get 25, but when you square the square root of 2, it's still just 2. So this becomes 50. And then you have x squared is equal to 25, x is equal to 5. Not a Pythagorean triple, because you still have that 5 square root of 2 hypotenuse, but at least the other side came out nice. So sine of theta, remember that sine of theta is opposite over adjacent, not opposite over adjacent, sorry, that's tangent, skipping ahead. Opposite over hypotenuse. So in this case, it's 5 over 5 square roots of 2. You can't leave it that way, so we're going to multiply the top and the bottom by the square root of 2. And I get 5 square roots of 2 over, now these two make the square root of 4, which is 2. So 5 times 2 is 10. And I can reduce that. The 5 and the 10 are going to cancel. You can't cancel the 2 and the 10 because the 2 is stuck underneath the radical. And that gives me the square root of 2 over 2. And then tangent of theta is opposite over adjacent. And that is 5 over 5, which is 1. Number 4. In a right triangle, theta is the acute angle. So this time I'll put it down here on the bottom, since we just did 2 with it in the upper corner. And cosine is adjacent over hypotenuse. So 7 over 10. I do need to find that third side. So 7 squared plus x squared is equal to 10 squared. 49 plus x squared is equal to 100. X squared is equal to 51. So that other side is the square root of 51. Cosecant of theta is, so you can look on your appendix or until you memorize it, but honestly, I don't even have it memorized. I think of it myself as the flip of sine. So it's going to be hypotenuse over opposite. That way I only have to memorize sine, cosine, and tangent instead of all 6 of them. So hypotenuse is 10 and opposite is the square root of 51. I can't leave it that way, so I'm going to multiply the top and the bottom by the square root of 51. And I get 10 square roots of 51 over 51, which is not reducible. And that's cosecant of theta. So 3 angles, 30, 45, and 60, occur really frequently in trigonometry. Therefore, it's important to memorize the trigonometric values for those angles. And notice, like I said, we're only going to learn sine, cosine, and tangent. The other 3 are just the flips. So for sine, it's 1 over 2, the square root of 2 over 2, and the square root of 3 over 2. Now, you can look at the triangles to get all these answers, but I'm just going to show you something kind of cool. And that is that cosine is, think about it this way, it's got the word co in it, right? It's just like sine, but it's it's complementary. So it's going to do the opposite of what sine does. So when sine is 1/2, cosine is square root of 3 over 2. Because that's its complement. See how 30 and 60 are complementary? And when sine is 60, cosine is 1/2. That might help you memorize this chart. You will have to memorize this chart. But 45 is complement to 45. So these are both square root of 2 over 2. And then tangent is going to be the square root of 3 over 3 and 1 and the square root of 3. And there will be ways to memorize those later, little tricks for it, but you haven't learned what you need to know the memory parts. So how do these trig values help us? Well, it helps you not have to use your calculator. So I look at this triangle and I want to know what the value of x is. And I think, well, when I'm looking at 30, x is considered adjacent, and then this is hypotenuse. So I'm going to use cosine. So cosine of 30 is equal to adjacent over hypotenuse. And of course, the first thing I do is clear my fractions. So now I have 8 cosine of 30 is equal to x. And I could type that into my calculator, but I could just look at my chart. Cosine of 30 is the square root of 3 over 2. The 8 and the 2 reduce to just 4 and 1. So 4 square roots of 3 is the value of x. Now, of course, that's only 3 angles. It's only you're only going to memorize 30, 45, and 60. So if you get an angle like 28, then you're going to use your calculator. So I'm going to do, let's see, I have adjacent and I need both hypotenuse and opposite. So for one of them, I'm going to use tangent. Tangent of 28 will be opposite over adjacent. And when I clear my fraction, I get 15. Tangent of 28 is equal to A. And then to get the C, I can use cosine. Cosine of 28 is adjacent over hypotenuse. Now, I didn't actually show the clearing fraction in this step because I think you guys are really good at it, and I think you can kind of do that in your head. But for some reason, when the C is on the bottom, everybody has trouble. Don't let that throw you. If the C is on the bottom, then that's what needs to be cleared. Super important. C, cosine of 28, is equal to 15. You do what you always do, even when the variable is on the bottom. And now you solve for C. C is 15 over cosine of 28. So let me show you how to type that into your calculator. Your first step is to hit this mode button. It's really important that your calculator be in degrees. So if you go down, we will learn about radian in a future lesson, but right now we're working in degrees. So kind of just highlight it, and then you can hit quit, which is second mode. So now that I definitely have it in degrees, I can literally just type it in. 15, my tangent button is right here. I know that's new for you. And then 28. So side A is going to be 7.976. And then the other one was 15 divided by cosine of 28. You can either do that because you don't have anything complicated going on, or don't forget you can use alpha F1 if you really need to see it as a fraction, which sometimes is important to make sure that you don't make a mistake. But in this case, it wouldn't have mattered either way. And that's what your side C is, 16.989. So I've written these two answers here for you. Now, as you move on to the next page, there's literally not a single new thing on either 3 or 4, and 4 has 4 parts to it that you can try. So I highly encourage you to do those on your own, but of course I am going to do them for you. So I look at this problem and I see that I need x. I always want to ask myself, how is it related to the angle? So it's considered the adjacent side, and this is considered the hypotenuse. So you look on your chart until you have it memorized, and you realize that that's cosine. So cosine of 45 is the ratio of the adjacent side to the hypotenuse. You clear your fractions. And you could type this into your calculator, but if it's a known angle, I would like you to leave it in its exact form. I'll know that you typed it into your calculator because you'll have a rounded decimal answer, because the square root of 2 is not a rational number. So instead, I would like you to leave it as a irrational number because it's more exact. So the 6 and the 2 cancel and leave you with 3 square roots of 2. This is more exact than what you would get on your calculator. For B, for A, B is 45 degrees. So I'm going to go ahead and fill that in, 45 degrees, and C is 5. And I want to know both A and B, and I know the hypotenuse. So to find A, I can use adjacent. Cosine of 45 is adjacent over hypotenuse. So A is going to be 5 times cosine of 45. Cosine of 45 is square root of 2 over 2. And so A is 5 square roots of 2 over 2. And then to find side B, it is opposite the 45. So I can use sine of 45 is equal to opposite over hypotenuse. I clear my fraction, and then I replace sine with the known ratio because it's 45. Again, I don't want you to use your calculator for 30, 45, or 60. So square root of 2 over 2. And it turns out that B and A are exactly the same, which my picture didn't show it because I'm just using the same picture for each one. But if this is a 45-degree angle and this is 90, this is also 45. And since the angle controls how big the opposite side is, it makes sense that if this is 45, it'll produce the same side as this one that has 45 degrees also. For B, A is 32 and B is 10. So I need to find side A. So I'm going to say tangent because A is opposite, but the thing that I know is adjacent. And tangent is opposite over adjacent. So opposite over adjacent. I clear my fraction. And since this isn't 30, 45, or 60, you can use your calculator. So I type that into my calculator, and A comes out to be 6.249. And then I also need to get side C. I was given adjacent, and then that's going to be hypotenuse. So that's going to be cosine. Cosine of 32 is adjacent over hypotenuse. Remember, this is the one that's just a little bit trickier for people. You do have to make sure that you clear the fraction first, and then you can divide both sides by cosine of 32. And C turns out to be, oh, crazy pen there, and C turns out to be 11.792. Letter B. Again, if you're still just watching, you should try these on your own. So obviously not drawn to scale. I'm just using the same triangle each time because this is 71 degrees, which is pretty big. So 71 degrees and C is 20. So if I want to know opposite, if I want to know A and I know hypotenuse, that would be sine. Sine of 71 is opposite over hypotenuse. I clear the fraction by multiplying both sides by 20. And A is equal to 18.91 and is technically 910. You would only do that if you wanted to remember that you did actually bother to round to the nearest thousandth, but it's not actually necessary. Excuse me. And then in order to find B, B is adjacent, so I'm going to use cosine. Cosine of 71 is equal to adjacent over hypotenuse, which is 20. Again, I clear the fraction, and I have no problem with your just doing that. You don't have to show this to both sides each time. And then when you do cosine of 71 times 20 on your calculator, you get 6.511. Now, one little way that you can tell if you've done it right is if this is 71 degrees, then this one is 19 degrees, which means angle B is pretty small, so side B should be pretty small. And angle A is pretty big, so side A should be pretty big, and comparatively they are. For D, I'm going to label B as 60 degrees and A as 7. So A is the adjacent side, so cosine of 60 degrees is going to be adjacent over hypotenuse. So I get C times cosine of 60 degrees is equal to 7. C is equal to 7 over cosine of 60. Now 60 is on our list, so you do have to fill it in as 1/2. And some people struggle here, got a fraction now. But if you make this a fraction and this a fraction, then you can do keep, change to multiplication, and flip. And you'll get that C is equal to 14. And then we also need this opposite side. So I'm going to use sine. No, that sine would actually mean that I would need to know C, which I do know C, but what if I did C wrong? So in order to use the given information, I'm actually going to use tangent. Tangent of 60 is equal to opposite over adjacent. So then I get 7 times tangent of 60 is equal to B. And tangent of 60 is the square root of 3. So this just comes out to be 7 square roots of 3. Ready to try some word problems on these? The word problems are what it's all about because that's what helps you understand why we learn trig in the first place. So a biologist wants to know the width of a river in order to properly set instruments for studying the pollutants in the water. So from point A, the biologist walks downstream. So let's just go ahead and do our river. I mean, he could just like get into a boat and tie a measuring, line to one side, and then he could row across, right? And then when he gets the other side with his measuring tape, then he'll know how wide it is. But he doesn't have a boat, and he doesn't have that long a measuring tape, I guess. So what are we going to do? We're going to use trig, and it's going to be very cool. So here he is at point A, and he walks 70 feet downstream and sights in point C, which is on the opposite bank directly across from A. So this is point C. And he has an instrument that allows him to find this angle. And that angle, without getting wet, that angle measurement is 54 degrees. So because he knows how many feet he walked and he knows this angle, without getting wet, he can tell you how wide the river is. So which trig function do I want? I know the adjacent side and I want to know the opposite side. So I'm going to use tangent. So tangent of 54 degrees is equal to opposite over adjacent. I clear my fraction and make sure my calculator is in degree mode, and I just type it in because it's not one of our known angles. And W comes out to be 96.347 feet across the river. A lot of times in these problems, we're going to be talking about the angle of elevation and the angle of depression. They are always measured from a horizontal line. Most people have no trouble with the angle of elevation. They're standing here and they call this angle to the top of a building the angle of elevation. So what's the angle of elevation to a flagpole, right? Or what's the elevation to the top of a mountain? It makes sense that if you're here, that angle is just how you get to the top. What people really struggle with is the angle of depression. So the angle of depression, a lot of times when you're drawing something, like a person at a spot, they're looking at the top of a building or something, or maybe they're looking at the top of a mountain. But if somebody else is standing on the top of the mountain and they want to know the angle of depression, it is not here. But that's where the triangle is. So people think that this is the angle of depression, but it's not. When he's standing on top of the mountain, he's looking out over the world. He's not looking straight down at his feet. He's looking out. And then he looks down and he says, ooh, how do I get back to my friend down here? So this is the angle of depression. Always picture the person that's up there as looking out. For another example, let's say, okay, now don't laugh at my drawing. It's going to be really bad. Let's say that you're in a helicopter and the helicopter is looking at a person that he's trying to rescue. And the question is, what is the angle of depression? Well, the pilot isn't looking straight down and then figuring out this angle, right? Not at all. The pilot is looking dead ahead It was a bad line. I got to erase it. The pilot is looking dead ahead, but then he looks down to see this person that he needs to rescue. That is the angle of depression. Think about it as the angle that he's lowering his vision to a new line of sight. So just watch out for this one. Angle of elevation, usually pretty easy. Angle of depression, not so much. So a parasailer is attached to a boat. So I don't know if you know what a parasailer is, but it's a guy in a parachute, but he's wearing a harness and he's attached to a boat. So he's getting pulled. It's not like he's just floating down from the sky. It's very cool. So this is a 72-foot rope, and the angle of elevation from the boat to the parasailer is 28 degrees. So we want to find out how high he is above the water. So, I know he's not even attached to this thing, right? Let's attach him to his parachute. So how high is he above the water? So I know the hypotenuse, and I want to know opposite. So I look at my chart and I say opposite and hypotenuse are sine. So sine of 28 is opposite side over hypotenuse. So I clear my fraction. I multiply both sides by 72. And I get 72 sine of 28, which is not one of my known angles. So you can just type it into your calculator, and it comes out to 33.802 feet. That's how high he is up in the air. Katoomba Scenic Railway in Australia is the steepest railway in the world. The railway makes an angle of about 52 degrees with the ground. The railway extends horizontally about 458 feet. So what is the height of the railway? So you have this train track, this railway. I'm not going to draw the train. It would be embarrassing. So horizontally, it covers 458 feet, but its angle is a stunning 58 degrees. So what is the height of the railway? So I think to myself, I want to know the side opposite, but what I know is the side adjacent. So this time I'm going to use tangent. So tangent of 52 is opposite over adjacent. I clear my fraction by multiplying both sides by 458. And then because this is not one of my known angles, I can use my calculator. 586.213 feet. I hope you're enjoying the word problems. I really like them. The Duquesne Incline in Pittsburgh, Pennsylvania has an elevation of 30 degrees. The track length has a length of about 800 feet. Oh, so this is the track this time. So this is another incline. It's the Duquesne Incline. There's also Duquesne University. And its angle of elevation isn't anywhere near as steep, even though I probably drew it exactly the same. Has an angle of 30 degrees, and the track length is 800 feet. So really the only place you could go wrong is not understanding that this time they didn't give you the horizontal distance. This one specifically said the railway extends horizontally, where this one says that the length of the track is 800. Find the height of the incline. So I want to know the side opposite, but I was given the hypotenuse. That's going to be sine. So sine of 30 is equal to h, 8 over 800. I clear my fraction. And because this is a known angle, I can go ahead and just look at my chart. It's 1/2. And so the height is equal to 400 feet. Okay, number 5. When you measure the angle of elevation from the ground to the top of a building, it comes out to be 32. When you move 50 meters closer to the building, the angle of elevation is 23. So here's my angle of elevation to the top of my building, and it's 32 degrees. But if I move closer, so I've walked 50 feet, now I'm going to have to look up steeper, right? That's why the angle of elevation changed. Now it's 53 degrees, because for me to see the top of the building, I have to kind of tilt my head back further. What is the height of the building? Okay, so to do this one, we're going to have to create actually a system of equations. This one's a little tricky. So I want to know opposite, and I know part of the adjacent. So I'm definitely going to be using tangent. And my first equation is that tangent of 32 is equal to opposite over, and I'm going to have to call this 50 plus x. I can't just call it 50 because it's this entire adjacent side. And then my other one for the 53 is that tangent of 53 is equal to h over just plain old x. So what's nice is now I can solve this system. I have two variables, I have two equations. I'm going to let h be equal to x times tangent of 53, and then I'm going to plug that into this equation. So tangent of 32 is equal to x tangent of 53 over 50 plus x. Still not an easy problem, but at least I've gotten it down to one variable. You might be thinking, but you got the wrong variable. What you really want is h. Well, I think that it's going to be easier to get x all alone first and then do it that way. But you can do it the other way if you want to. I'm going to clear my fraction, so 50 plus x on both sides. And at the same time, I am going to go ahead and calculate tangent of 32. So tangent of 32 is going to be 0.625, and tangent of 53 is going to be 1.327. And that way, when I keep working, I'll have actual numbers to work with. So 50 times 0.625, because I'm distributing this 0.625 to the 50, is going to be 31.25 plus 0.625x. And on this side, my 50 plus x canceled, and I just get the 1.327x. So I subtract 1.327 minus 0.625, and I get 0.702x is equal to 31.25. 31.25 divided by 0.702 is 44.516. And now that I know that, I can go back and find h, because h is x times tangent of 53. So I actually still have x in my calculator. I'm just going to hit store, and then it won't even use the rounded answer, times tangent of 53. And I get h is equal to 074 meters. 074 meters. So that was a tough one, but it was good. It was a little reminder of using substitution and systems of equations. So these last two are challenge problems. They're really just trying to get you to think. It says, use the figure to answer each question. Which side is adjacent to theta? So next to theta is the x. And which side is opposite of theta? Y. So now that we know that, show that cosine of theta is the same as sine of 90 minus theta. This is what I was saying about them being sine and cosine. This is going to help you hopefully understand why that's true. Because cosine of theta is adjacent over hypotenuse. But then if you want to do sine of 90 minus theta, this is your angle. This is the angle that you look at. And if you're looking at that angle, then now this becomes opposite. And once this is opposite, then it's x over hypotenuse. So that's why sine of this angle always ends up being the same as sine of the other angle, because sine and cosine are co-functions of each other. Last one, number 2. Consider a semicircle with a radius of 1 unit. So this distance right here is 1, and this distance right here is 1. These little symbols mean congruent from geometry. Write the values of the 6 trigonometric functions of the angle theta. So here's my theta. So I'm going to look at this and say, well, on my theta, I can't use trig for this one because trig requires it to be a right triangle. So you're going to have to ask yourself, where is there a right triangle? Well, if this distance is the same as this, then we call this triangle an equilateral triangle. That means all sides are the same. But it also means that it is equiangular, which means this is 60, and this is 60, and this is 60. And then these two angles form a straight line, which is 180. So this must be 120. And then if this is 120 and these two are the same, then these two angles are also the same. So what's left in my triangle, 180 minus 120 is 60, but there's two of them. So these must each be 30. A little bit of thinking there and some geometry, which I know you haven't had geometry yet, so that could be a little bit tricky. But now that I know that theta is equal to 30 degrees, I don't even need opposites and adjacents and hypotenuses. This is one that you should have memorized. So sine of 30 degrees is 1/2. Cosine of 30 degrees is the square root of 3 over 2. Tangent of 30 degrees is the square root of 3, just the square root of 3. No, over 3. And then if let's see, they want all 6. So then cosecant, and you can write just theta, it did just say of theta, but I know that it's 30, is 2 over 1. But you don't have to write the over 1. You can just write 2. And then secant of theta is going to be 2 over the square root of 3, which you can't leave like that. You do have to rationalize it to 2 square roots of 3 over 3. And cotangent of theta will be 3 over the square root of 3. But when you rationalize that, it actually comes out to just the square root of 3. Okay, that is it for section 9.1. Have a great day.